Welcome back to our online lecture series in Textile Effluent Treatments. So in the previous video, we saw about the tertiary treatment method, simple definition and a simple outline of this tertiary effluent treatments. Then we saw the classification of tertiary effluent treatment methods, and then we saw about evaporation method, both steam evaporation and solar evaporation. So in this lecture video, we'll be continuing the tertiary treatment methods, in which we'll be seeing about advanced oxidation process, then we'll see activated carbon treatment, and finally we'll see about ion exchange process. So first we can go to advanced oxidation process. So advanced oxidation process in a broad sense is a set of chemical treatment procedure. So it is a chemical treatment procedure which is designed to remove organic and sometimes inorganic materials in water and wastewater by oxidation through reactions with hydroxyl radicals. Okay, so OH radical or sulfate radical. Okay, SO4 dot minus. In real-world application of wastewater treatment, however, this term usually refers more specifically to subset of such chemical processes that employs ozone, hydrogen peroxide, and or UV light. So advanced oxidation process systems uses or combines two or more oxidizing agents to create hydroxyl radicals, the ultimate oxidant for elimination of organic pollutants. So this hydroxyl radical is the ultimate oxidizing agent which eliminates the organic pollutants in wastewater. So this advanced oxidation process was first proposed in the year 1980s or in the time of 1980s for drinking water treatment, and later it were widely studied for treatment of different wastewater. During the AOP process, hydroxyl radicals or sulfate radicals are generated in sufficient quantity. These radicals remove the refractory organic compounds, traceable organic contaminants, or certain organic pollutants, or to increase wastewater biodegradability or a pre-treatment prior to ensuring biological treatment. So generally the treatment efficiencies relies heavily upon the selected AOP type, physical and chemical properties of target pollutants, and the operating condition which is adopted. So it would be noted that other mechanism besides hydroxyl radical or sulfate radical generation may occur during the AOP oxidation and contribute to the reduction of the target pollutants. But the major oxidants produced or the radicals produced are hydroxyl and sulfate radical based oxidation. In advanced oxidation process, although make use of a different reacting system, are all characterized by the same chemical nature, which is production of OH radical, and this OH radical is highly reactive and they have a higher rate constant. This AOP process is a combination of ozone, hydrogen peroxide and UV, as I said earlier, and these oxidants effectively decolorize dyes. However, it did not remove the CODs completely. So here you can see an advanced oxidation process in which the initiators are hydrogen peroxide, ozone or water. The catalyst used may be UV light, ultrasonic semiconductor or metal, and this together forms the OH radical. And this OH radical reacts with the organic pollutant RH and convert the alkyl group into alkyl radical, and this alkyl radical get oxidized to form water and carbon dioxide as the final end product. So the mineralization of organic pollutant in advanced oxidation process could be given by this mechanism here. So RH is an alkyl group which reacts with the OH radical to form R radical, which is alkyl radical plus water. This alkyl radical again reacts with oxygen to form RO2 radical. 2 RO2 radical reacts to form a complex which is unstable, and it further decomposes to form carbon dioxide and water using by some mechanisms. Okay. So classification of AOP can be done using chemical reagent, photocatalytic process, or direct H2O2 dissociation. Anyone can form the OH radical. So in general, AOP can be classified into non-photochemical and photochemical process. Non-photochemical does not uses UV light, while photochemical process involves UV light. And here the highlighted photochemical processes are the important processes which you will be studying. So O3 along with hydrogen peroxide and hydrogen peroxide with Fe2 plus, which is Fenton's reaction. Then we have O3 along with catalyst, ozonation, and we have hydrogen peroxide and with UV, O3 with UV, O3 hydrogen peroxide with UV, and you have photofenton, which is H2O2, Fe2 plus and UV, and we also have UV/TiO2, which is photocatalytic reaction. So Fenton's reaction can be given like this. So Fe2 plus hydrogen peroxide reacts to give Fe3 plus ion plus OH minus ion and OH radical. So here it is a reversible, it exists as a reversible reaction, and this OH radical brings about the decomposition of the organic matters present. In ozonation process, we all know ozone is a powerful oxidizing agent for both water and wastewater treatment. And here, once dissolved in water, ozone reacts with great number of organic compounds in two ways. One is by direct oxidation as molecular ozone, or by indirect reaction through formation of secondary oxidants like hydroxyl radical. So the hydroxyl radical is formed by the from above reaction 3O3 plus H2O along with the OH minus ion in alkaline environment gives you 2OH radical. So the conventional fine bubble contactor is most widely ozone generator, used because of the high ozone transfer efficiency of about 90% and due to its high performance. So the results presented by few researchers reveal that ozone decolorizes all dyes except non-soluble disperse and vat dyes, which react slowly and take longer time. The color removal using this ozonation from textile wastewater is dependent on dye concentration. So dye concentration is an important factor when we apply ozonation for color removal. Next, O3 along with UV. So according to the Rain, conventional ozonation of organic compound does not completely oxidize the organic compounds to carbon dioxide and water in many cases. So the remaining intermediate products in some solution may be toxic or even more toxic than the initial compound. And UV radiation could complete the oxidation reaction by supplement to the reaction. So use ozonation along with UV. It's the most effective method for decolorizing dyes compared with UV alone or ozonation alone. So ozone with UV treatment is recorded to be the more effective method of removing colors and COD removal. Next is hydrogen peroxide with UV. So the oxidation of textile water with hydrogen peroxide alone is ineffective, as I said earlier. So along with UV, the reaction is more highly effective and the color effective is more good when in H2O2 along with UV also. And another one is O3 along with H2O2. So here they together produce more hydroxyl radical, and at higher pH, very small concentration of H2O2 will dissociate into HO2 ions, and that can initiate ozone decomposition more effectively than OH minus ion. So they together constitute to the greater reactions. Some advantages of this AOP process are they are effective to eliminate inorganic compounds in aqueous phase. So rather than collecting and transferring the pollutants to another phase, this is an effective method. Due to remarkable reactivity of OH radical, it virtually reacts with almost every aqueous pollutants without discriminating. So it readily reacts with all pollutants. And AOPs are therefore applicable in many, if not all, scenarios where many organic contaminants must be removed at the same time. So we will adopt AOP at such conditions. Some heavy metals can also be removed in this AOP process. In some AOP design, disinfection also is achieved in the same process. So since the complete reduction of product of OH is H2O, AOP do not introduce any new hazardous substance into the water, which is an advantage. So next is activated carbon treatment. So it is most commonly used method for dye removal, and it follows the method of adsorption. So the process also removes toxic chemicals such as pesticides, phenols, cyanides and organic dyes, and the absorbent material commonly used for this method is activated carbon. So in general it is called adsorption technique. So we can say the most commonly used adsorbent is activated carbon. It is manufactured from carbonaceous material by such as wool or wood, coal, petroleum products, either by chemical activation or thermal activation. So other components for adsorption can be activated clay, silica, fly ash. So it is effective for absorbing cationic, mordant and acid dyes, and to a slightly lesser extent dispersed dyes, direct dyes, wet dyes, pigment and reactor dyes could be adsorbed using this activated carbon method. So disadvantage is that activated carbon method is effective and it has to be reactivated. So this can result to about 10 to 15% loss of the sorbent. So that is a disadvantage. Other than that, it is a beautiful technique to remove color from wastewater. So only thing is that it is somewhat expensive and it needs regeneration. So next comes the ion exchange process. This you all know so I am not going to explain it deeper. So this ion exchange process is normally used for removing inorganic salts and some specific organic ionic compounds such as phenol. So all the salts are composed of positive ion of a base and negative ion of an acid. Okay, so ion exchange materials are capable of exchanging the soluble ions and cations with the electrolyte solutions. So this ion exchanger system used for wastewater treatment have been based on the process called desal, which utilizes a three-step operation. So a weak base anion resin in bicarbonate form, then it uses a weak acid cation in hydrogen form, then it also uses a weak base anion resin in free base form. So a three ion exchanger will be there. One is a weak base anion exchanger first. The second one is weak acid exchanger. Then we have weak base anion exchanger. So in series the wastewater is passed and it is treated in ion exchange process. Okay. So these are some techniques. Some advanced oxidation process we saw, then we saw about the activated carbon treatment, and then we also saw about the ion exchange process. So in the next video we'll be seeing about the membrane technology which is used for treating the wastewater. So we can end the video here. Thank you.